so I'll be talking about pathology in early tetrapods, and there's been a lot of research into early tetrapods in terms of the rise onto land, but it's equally important to look at the tetrapods around that time period that stayed aquatic or maybe became secondarily aquatic to find out more about the evolution of early tetrapods in general. So I'm working with Crassigyrinus scoticus, which is a very unusual animal from what is now Scotland. It's about 320 million years old. It was a large aquatic predator about 2 meters long, but it has a very unusual morphology because the ulna was only about this big. So very reduced forelimbs, pretty reduced hind limbs. And when this specimen was first discovered and the first postcranial material that was found, they found 4 ribs that had fractured and then completely healed, which you can see by the ankylosed bone here and here. And they also found an unusual morphology in the distal femur and the proximal tibia, and it's on both sides. So the femur is the left and the tibia is the right. And this is unique to Crassigyrinus, and it was initially interpreted as being a functional feature due to maybe there was a ligamentous attachment if this animal was using its back limbs to paddle in the water to prevent dislocation. But I took CT scans of these specimens, and it becomes apparent that this is a pathological feature. So these scans are a little hard to see, but you can see the cortical bone here, the denser white, and then this is the trabecular bone. And then this growth looks very much separate, so it's probably secondarily depositing bone here, and you can see there's some cortical bone growing here. Same view, but transverse section right here. And then this is in the tibia, a very similar thing. So this is what it looks like on the actual bone. And so this led me to conclude that it's either due to some sort of single traumatic event, so maybe we don't see a fracture line, which is unusual, and it's only found on one side of all of these bones, which is also unusual. But the fact that the cortical bone is so distinct makes it look like it's some sort of pathology that's either related to a single trauma or maybe repeated stress, so more like osteophytosis, where the bone is remodeling to compensate for that stress. So I looked at other early tetrapod literature, and I found a very striking similarity in the proximal radius of Oceanotus. Oceanotus is also an early tetrapod, about 10 million years older than Crassigyrinus, but similar depositional context. And a paper used this pathology on Oceanotus to claim terrestriality in this animal because they said this fracture must have happened during a fall on land because only that loading environment could have caused that injury and the subsequent bone remodeling. But since we see this as a very similar injury, and you can see that both in the cross-sections and the models, and we know Crassigyrinus is aquatic, so this sort of injury can't be used to infer terrestriality in early tetrapods. So to conclude, Crassigyrinus was able to remodel bone in response to either repeated trauma or a single traumatic event. We cannot use this sort of pathology to infer terrestriality, and I'm going to be looking further into the evolution of being able to remodel bone, because we also find lungfish rib fractures that look very much like the Crassigyrinus one, so it seems to be a more basal adaptation and arose before animals were being exposed to the loading environment of land. Thank you.